Thank you. Good morning, everybody. Thanks to being wake up and coming to my talk. So my name is Jean-Marie Verdun. I do work at HPE within the advanced engineering team. So my role within that team is to overlook what's going on into the open hardware space and cherry picking the best of it to introduce this technology within the ProLiant family within a 3 to 5 year scope. So the idea behind that is just to try to understand where the open hardware projects are heading to and incorporate this technology inside our product and giving back feedback to this community on how to enhance and improve this product. I'm working at HPE, so that's a huge company. So do not expect any kind of revolution from huge company. Especially a company which has been created decades ago with more than 60,000 employees around the world, being present into more than 70 different countries. So what you can see on this slide is our new headquarters in Houston. So this is where we are mainly driving engineering activities. But what is really critical is really to understand that open hardware and open source firmware is really disruptive for companies like us. So I'm part of the open source firmware community since I would say a couple of years or perhaps a decade. And I'm also working inside a company which is having extremely hard time to take decision and how to introduce new technology. At the early stage, I was thinking, that should be easy just to introduce new technology inside our product portfolio. But when you start thinking about it, it's pretty hard. And let me just give you one example. So we are shipping millions of servers per year. And these servers have to be supported in more than 90 different languages. So, and we have to ship the exact same product everywhere around the world because we qualify the product, we certify that it works, and we need to be able to maintain this product during the whole life cycle of the product. So when we are heading to a new technology, the first question I'm getting from the support or the supply chain, hey, does your stuff works in South Korean? Or where is the language package for Japanese? Or what about the Hindi? I say, okay, let me check that and all these kind of issues. And you are quickly discovering that we are mainly focused as being an open source firmware community on the technology, and we are not focused at also, hey, how can people really use this technology around the world? And I know in some cases this is extremely boring, and I'm going to describe you my journey at HPE, and we will be discussing also about technology. Don't worry about that. But that is something which is extremely important to understand. If we want open source firmware to be successful one way or the others, we will have to fix all the small hurdles that early adopters are facing when we try to deliver them this technology. And trust me, I've been able to convince HPE to start enabling open source firmware on our platforms. It took me about 3 years just to get it done. And you might be thinking that 3 years is a very long period, but everybody inside the company is telling me this has been super fast. and I got that thing which says, fast? Are you sure about that? I must admit that there has been COVID in between. So, and this has extremely complexified our capability to take decisions and review new technology. What we also have to understand is, what about legacy? So HP is not a startup. So that's a company which is shipping product for decades, as I said. And we have firmware today. So open source firmware is in some way an alternative to something which does exist. And we have to understand from where we come when we want to introduce something new. What is the value that we are going to bring into our product if we are enabling something new? And when you looked at the history, we are working on VMC management firmware for about more than 20 years. And we are developing also the ASIC, which are running this firmware. And that is also something critical to understand when dealing with HPE. So we are designing the hardware and the software which run on top of these hardware platforms. And we are designing the hardware with the firmware in mind. So we do not put any extra features just to run an alternative operating system, for example. And our hardware has not been designed to run Linux. It has been designed to run real-time operating systems with very few hardware capabilities. And we had to wait a lot of time to be able just to put Linux on the ASICs, which is running the idle firmware. And the main reason behind that is we needed just to extend the idle firmware up to a stage we needed an IOMMU, for example, within the SoC. So during a long period of time, we didn't have any kind of IOMMU within the SoC because we didn't need it. So, and as long as we didn't need it, there was no reason to implement it because it costs money, it increased the complexity, and this can be a security issue and challenge. So why doing something that you do not need? And since IDO 5, as we can see, the software stack into IDO is becoming more and more complex. And the main reason behind that, it's not because we want it to be complex. That's because we have customer demand. So keep in mind, big corporations like HPE or competitors are driven by customer demand. So most of the time, we do not do something that a customer doesn't want, or we are overseeing the demand and trying to build systems which are going to match with the market demand. So if the firmware is complicated, that's also because our customers are needing these features. Probably not all of them. So most of our customers are using probably 10 to 20% of the subset of the features which are standing into our firmware. But with the whole mix of the customer base of HPE, we need all of that. And when we are enabling something new, we need to explain to our customer, hey, this is the benefit of these new things, this is what you can do with that, and this is what you are going to lose. Because in many cases, a disruptive technology is in some way a big jump in the past. So when Linux has been introduced to the x86 server space, so it was competing with Unix, and the first version of Linux was really not in pair with the professional Unix implementation. It has been a success, for sure, but you are always losing some kind of functionalities, and you need to understand that, and you need to explain that to your customers. So, while enabling Linux on our BMC right now, so GXP is the name of the ASICs, so that's the hardware which is running our idle firmware, and there are a couple of reasons. The first one is we are seeing some kind of concentrations within our customer base. So in the past, our customers were purchasing a few numbers of servers, let's say 10, 100, but it was extremely rare to have a customers which were purchasing thousands of servers. And with the cloud revolutions, with the concentrations inside data center space, what we see is more and more people deploying thousands of servers. But you do not manage thousands of servers the same way that you are managing just a few servers. And the control plane is now fully integrated within the complex infrastructures running Linux. And that is something which is critical to understand. And which is that is also increasing the pressure on getting a user interface within the BMC, which is getting closer and closer to what people know. And what people know is roughly Linux. And that's really also critical to understand that getting the Linux kernel everywhere is something which is easing the life of our customers. And if they could run a Linux environment on the BMC or the ROM side, that could make sense. Linux is probably not the perfect option today. So we could do open source firmware in a better way. But as I said, let's try to avoid a revolution, but let's try to build an evolution. I think it's really critical. And that evolution has to be successful into multiple steps. Instead of jumping to the final perfect options, let's try to move the market in a step-by-step approach. There is also a trend. So we spoke a lot about security yesterday. So people are more and more caring about security threats and how to address them. So we can see a split within our customer base on how to address that. So some of our customers are purchasing from HPE because they want us to be liable for the security. It means, hey, you got your idle firmware, you got your ROM, I want you to provide me the security update, and I don't want to take care about that. I'm trusting you. That's a way to approach that. And the insurance company around the world have been pretty efficient to build business around this approach. So there is another option, which is, hey, I don't want you to take care about the security of my systems. I want to own it. And I want you to give me the capability to own my own security model. And right now, as of now, HPE was not able to do that because we have our proprietary technology, which is not based on Linux. And it was extremely complicated to try to explain to our customer how this technology works. And it's not scalable. And the way we want to address it is just to give the opportunity to our customers to run their own firmware on top of our hardware. And we will see how we are going to do that. We have also more and more requests from customers who are purchasing thousands of servers. Unfortunately, they are not purchasing these thousands of servers from HPE only. We do have competitors. And they complain about the compatibility between these competitors. You know, we are trying to build up standards to manage machines. So you probably heard about IPMI, Redfish, all of these high-end user interface, API-based, which are supposed to be standardized between vendors, and which in the end are not implemented the same way between vendors. And this is a massive mess if you have to manage thousands of servers from multiple vendors. So one way to work around this issue is to enforce the vendors to support your own software stack, telling them, hey, instead of giving me your firmware, I'm going to build my own firmware stack, and you are going to put it on your machines. And if you are running the same firmware stack on all of your hardware infrastructures, you have a common base. And you know exactly the bugs that you are going to face, because this is still software and there is bugs. And there's also bugs into the hardware. So you need to know what's going on and own that. And we are seeing more and more requests regarding this. And last but not least, the most important part is all BMC hardware is finally capable to run Linux. So, and we can boot Linux, and do not expect extreme performances, because when I'll be disclosing today what's under the hood. So what kind of CPU we are using and the SoC architecture. That's not a super high powerful systems, but keep in mind, the main reason is this has been designed to match the requirement that we had to run the idle firmware. And that was the critical things. Speaking about security, so as you might be familiar, HPE has introduced Silicon Root of Trust solutions within their Gen 10 systems. It was about 5 years ago. So Silicon Root of Trust is a great thing. And I'm going to discuss a little bit about security. We all want secure systems because that's critical. All data needs to be safe. But the challenge is the more secure the system is, the more complicated it could be to manage and to upgrade and to resell and so on. And with Silicon Root of Trust, when we designed it, we didn't envision that we had to run something different than an HPE firmware. And this has been extremely complicated on our side. So we were explaining to our customers, hey, we got a secure platform. It's running only HPE firmware. And now we are going to tell them, hey, we got a platform. It's running to run HPE firmware. And by the way, other people will be able to build their own firmware and run it on the same platform. So how do we manage the security? And what we have decided to do is to build what we call a chain of trust. And that's the first step that we took and we prototyped. So whatever happened, a system needs to have a owner when it's getting out from manufacturing. And when we ship it to our customers, the owner of the firmware is going to be HPE. So this is the current model. But if somebody wants to run their own firmware on top of an HPE platform, so you will have to get back to us first. Send us some public key. So just that we can sign it within a binary blob, and we will giving you back that binary blob. And that binary blob is going to be identified by our bootloader saying, oh, there is that chain of trust which has been put in place. And the next stage of the boot is going to be signed by this key. And that is something which is critical. And we have enhanced the security by integrating within the binary blob what we call the ASIC ID. So the ASIC ID is a unique identifier per GXP ASIC. So it's burned at manufacturing, that's unique. and which means that only your firmware can run on your platform. That's also something which is critical to us. So how could we deliver the same kind of level of security for people who are running open source firmware or people which are running proprietary HP solution? It took me a lot of time to build up that solutions, get it approved by our security councils and moving forward into the right direction. Trust me, when we try to change the security of the HP platform, that's a lot of paperwork and a lot of engineering meetings because we need to validate that it's not going to be a security threat to our current customers and to our upcoming customers. Not everything is disclosed into that deck because I just have half an hour. I cannot disclose everything into half an hour. But if you have questions, I'll be displaying some mailing list address that you can use and send us the questions. So the people who are reading this mailing list are HP engineering people. So what's under the hood? So what is the GXP ASIC? So when you open up an HP servers, you will be one ASIC with some silkscreen written on it called HP ILO. So ILO is the name of the firmware. The name of the ASIC is GXP. So if you meet somebody from HP engineering and they speak with you about GXP, that's really the ASIC and the underlying hardware. You must be aware about that. So the GXP ASIC is an SoC. It's based on an ARM core. That's a Cortex A9 based core. It's an aging technology, I would say, but it's really good enough for what we have to do. So there is a DDR3 and DDR4 interface. So in fact, we have upgraded the ASIC. I think this was 12 months ago or 18 months ago because we were not able to get enough DDR3 chips anymore. So we said, okay, we probably need to switch to DDR4. We really dislike to change that hardware, that piece of hardware. So the main reason behind that is when something works, why do you break it? So you need to break it only when you need to break it. There is a couple of clocks. The main reason why we have two clocks is mainly because we can support some kind of CAN bus within the ASIC. So the CAN bus is used into very complicated HP systems like Superdomes or other machines. So that ASIC is used into most of the HP hardware solutions, from the edge servers up to the supercomputers that we are delivering to the US government or the various governments around the world. So we got two network interfaces and some VDR arts, which are driven on the motherboard. So the ASIC has VGA adapters. So that VGA adapters is routed to the host, and you can plug in a display. Some customers are requesting us to remove that VGA adapters. We don't do that. We don't do custom things with our ASIC, so we just have one version. There is a VGA adapter into all of them. So what we can do is disabling the support of the VGA through software if you want to, but that piece of hardware will be there, not forever, but it's there. We got support for some SPI flash, and we got an expansion bus where we have an NVRAM which is connected to that expansion bus. And there is a direct connectivity to the source bridge and what we called also a CPLD. So as to save space on the ASIC package and being able to reuse the same ASIC within multiple different system configuration, we took the decision to put the GPIO interfaces into an FPGA. So roughly a CPLD is a small FPGA. And we have a serialized protocol between the ASIC and the CPLD that we call CIF. And we are releasing currently what's going on within this protocol into the Linux kernel. So everything that I'm disclosing today, you will be able to learn about it through either the Linux kernel, U-boot, or the user space environment. So everything which is machine specific is within the CPLD in some way. The challenge that we face when we port Linux to the GXP ASIC is that there is no abstraction layer into the Linux kernel for this kind of devices, like a CPLD. So the GPIO and the fan controllers, all of these kind of things are currently implemented into the CPLD. So we start dealing with direct liquid cooling and all this kind of new fancy cooling technology. The GXP ASIC has to be able to handle that, and this is also driven through the CPLD. Any kind of sensors are also coming from the CPLD. So we have some kind of I2C interfaces. So there is 8 I2C buses which are available on the GXP ASIC. But in some cases, that's not enough for some kind of servers. And that's also something that we needed to address. So what's under the hood? So that's the SoC, roughly, what you can find within the SoC. So we got a PCI block, and that PCI block is the connectivity between the ASIC and the host. So you can find some proprietary interfaces which are related to Intel only, like the PEKI bus interfaces, which is used to retrieve some critical data from the Intel CPUs, like the core temperature and the voltage feedback from the core. We got an LPC interface. The LPC interface is pretty interesting. I really like it. This is able to emulate an eSPI. So roughly, we can boot a host without getting access to the physical SPI interface directly. So we can map a memory region from the ASIC and use that memory region to deliver the ROM to the host. It could be extremely relevant in some kind of specific situation. So we got the Cortex-A9, the standard AHB bus, where we are connecting everything, memory controllers, LPC engines, MAC, and the CPLD interfaces, and the SPI engines. The SPI engines, we got 3 of them. So that's mainly because we have 3 SPI chips connected to this ASIC. So one of them is the system ROM, one of them is the boot flash for the ASIC itself, and the third one is used to store the UEFI variable store, or it could be used by the host to store anything that he wants to store into that. So that specific SPI part is memory mapped into the host region. So you can get access to it directly through the PCI memory address space. And that's also pretty efficient if you have to store critical data between system boots and wants to retrieve this data. So just to give you an example, the PEI interface is storing some critical information about the DIMMs, avoiding to have long memory DIMMs retraining each time you turn back on the power. I don't know how familiar you are with PEKI, but the PEKI bus is very proprietary to the Intel platforms. So we had to implement that into our ASICs if we wanted to drive properly host based on Intel technology. EMD and Ampere, so you might be familiar that we are now supporting into the Prion family ARM CPUs, are all using the I2C interfaces. So Intel has decided to go for something proprietary, and that's something we had to support. What is important is about the CIF. So the CIF interface is something simple. That's a proprietary bus, so that's HP only. We are thinking about trying to get that stuff standardized, and that's probably a discussion I'm going to ramp up with the OCP community in October, because we are heading into a direction where a server motherboard is going to become more and more modular with DCSCM, DCMHS form factor, and all these kind of things. And we need more and more FPGAs to interface the GPIOs between the various boards and authenticate the boards. But if we are implementing these solutions by ourselves, either HPE, Dell, or all ODMs, or Google, Facebook, and the hyperscalers, so there will be no compatibility between modules, and that will be a shame, because the success of a modular platform is to deliver modules which can be compatible between each other and between vendors. And it's really critical that we find a way to standardize the serialization interface. So we might be offering the opportunity just to reuse what we have done. I'm pretty sure that a lot of people will tell us this is a piece of crap. I would say that's probably the case. We could do better things, but at least we know that it works for about more than 15 years, and it has been delivered on more than 20 billion machines. So I'm not saying this is the state-of-the-art technology, but at least it works. So we can prove that it can work. So it's a packet protocol. Everything is set up automatically by the hardware. So if your board layout is not good, so it won't work, and it happened in some cases. But when it works forever in some way. So you don't need to set up anything within the software interface. This is focused on the three primary things I mentioned earlier. So GPIOs, thermal and cooling capabilities, PWM, signal generations for the cooling subsystem. So regarding the GPIOs, we got about 128 GPIOs which are available through the CPLD. So we think it should be good enough. As funny as it could look like, we get some use case where it's not good enough, and it's a little bit tricky just to try make it fit. Keep in mind that we are also designing very complicated systems, so we are not designing only single socket or dual socket machines. So in some cases, the systems can be very complex, and that's also why that we need to find some good stuff. We are not always following what the chip vendors is requesting us. So SIO signals or power good and all these kind of things. So the power sequencing is HPE proprietary things. The main advantage that we have to re-implement something proprietary is that we are using the same power sequencing between Intel, AMD, and Ampere. So roughly, we really build up something to abstract what the chip vendors are trying to enforce us to implement into the hardware. We are doing that mainly because we just want to reuse the same engineers, and we don't want to retrain them each time they have to design something from a different chip vendors. And that's also important. And the other thing is the ILO engineers do not need to know anything about the hardware. So they just need to know what's under the hood and specific to HPE. So regarding thermal management, we can generate up to 8 PWM fans. So it means that within the standard servers, you can have up to 8 fans. If you need more than that, then we are screwed, or we need to find some alternative solutions. And we got some watchdog timers and fan fault detections. We also have tachometers, but we can close that debate super fast. We don't use tachometers into HPE platforms. So we just generate PWM signals, and we just want you to use these signals. I'm speaking way too slow. So that is something that we are disclosing right now. Yesterday, we were speaking about documentation. We don't have an end-user ready documentations, but we start to release what's going on. And so this is the memory mapping, the address space, the host registers access, the GPIO specific address space, and the CPLD extension bus. If you start reading the Linux kernel, you can find some documentations. I'll be releasing on the blog more and more technical details about how these things works if you want to rewrite your own device drivers. What the strategy that we took is just to publish working device drivers and with, I shouldn't say that, self-documented code, because I hate that approach. I really hate that. But what we wanted to do is just to prove that it could work. So, and the way to do that is just release the code and write the code first, release it, and let's discuss with the community to get feedback on how to improve that. So we focused on the Linux kernel. I'm not saying we are focused on OpenBMC. I'm focused on the Linux kernel. Then after, you can boot whatever you want. I don't care about what our end users are going to run on this platform. It could be UBMC, OpenBMC, or anything else. I'm just trying to explain you can boot Linux, you can boot open source firmware and software on top of these ASICs and manage HPE machines. I need to drop some slides. So if you have questions, I'm going to stop there. I think this is, no, that would be a last slide and I'd be done. What was critical is when can I start playing with this? So that was the first question. So we built up a proof of concept with Gen 10 Plus. So the Gen 10 Plus proof of concept has a ton of limitation. So Gen 10 Plus is the current shipping system from HPE. So we could convert a system from ILO to OpenBMC, but you couldn't move back from OpenBMC to ILO. So as an open source firmware adopter, you do not care about that. But you should be caring about it. Because as a manufacturer of millions of systems per year, I want my system's lifetime to be extended as much as possible. because otherwise this is ending up to be trash. And that's not really good for the planet. And we should be all caring about what's going on. So being able to move back to INO allows the same systems to be reused by a standard HP customers. And that is really critical because we still have a lot of customers, and probably 99% of our customers are currently enjoying what they purchase from HP. The main reason behind that is otherwise they won't be purchasing from us. So we also need to understand that. And if you want to resell one way or the other your systems to somebody else just to purchase a new one or switching your infrastructures, you need to be able to put it back into a well-known system configuration. The other things which was due to that, so we had limitation around the warranty. And what is critical when we are enabling open source firmware on the Gen 11 machines is we want to provide you a standard warranty. So either you are running IO or you are running your own stack, you will be benefiting from the warranty. For sure, we will be probably monitoring at the early stage the failure rates, because by implementing your own firmware, you can break the fan algorithms and you can face thermal challenges. But we think that we can work that with our customers, especially the early adopters, and train them and also learn from that feedback. I think something is important. I'll be stopping on that. So you can see a group picture of part of the engineering team working on this project. I'm on the pictures, and we got a few other team members here. We are really open to what's going on open source firmware. We are willing to give the opportunity to our customers to use them. So I'm not going to say open source firmware is better than IO, IO is better than open source firmware, because I do not care. I care about providing the right solution to my customers. And my customers are old enough to know also what is the right solution to them. And I want to collaborate with them too. And the way to collaborate is through either meetups or mailing lists and so on. So if you want to work on GXP ASICs, so we set up two mailing lists, one for the people who are interested by the Linux kernel and one who are interested by U-boot, the bootloader that we are currently using and enabling. So you can send us email there. So you can help us to clean up the code. You can help us to improve the functionalities or debugging the code. But if nobody is making it, that's fine. HP is going to make it. So. And the strategy is this one. With Gen 11, we won't be shipping any systems with open source firmware or OpenBMC and so on. What we will claim to our customers is you will be able to switch to open source firmware and switch back to IO, but you will have to recompile your own firmware stack. And here is a proof of concept on how to recompile OpenBMC, for example, on these platforms. So we will be pushing all the patches which are required inside the OpenBMC, the Linux kernel, and the U-boot repository. We do not have any plan to fork anything. We just want to go upstream. That's a big pain to us, trust me, because all of my developers are not open source developers. All of them have more than 25 years of experience at developing firmwares. And now I'm trying to condemn them to code styling, which is totally different than what they are used to do. And different tools, everything is different. And we are also exposing them. That's a challenge. And I just wanted to conclude on that because I faced an issue within my team and I really hate that. So as you can see on these pictures, there is a lady on that pictures. And we lost her. And the main reason is because when she started to post code, so she was really afraid about the behavior and the feedback she got from the community. And that's unacceptable. And when I look at this room, I don't think this is intended, but is there any woman in this room? Raise your hand. There is one, only one. And I think that's an issue. That's an issue because diversity is really critical to be successful. People think differently depending on the situation. And I was extremely sad when we lost her. So she said she was a very experienced firmware engineer, and she left HPE in the end because she was allocated to the open source firmware project, and she faced these issues. I spent a lot of time discussing with her about these challenges, but that was the way it was. So when we build a new technology and when we build a a new approach, it's really critical to be open-minded. And I think that's the most important part. You won't be perhaps satisfied about what HPE is doing. That's fine. You have the right to have different opinion, but stay cool and try to explain why your solution is better than the one we are promoting in a smart way, instead of yelling anywhere or everywhere, because this could have impact on people. That will be the end of the talk. I'm sorry, I probably speak too much. Thank you. Just one last thing before we start the Q&A. I came with a board. So this is one of the first HP board that we are on which we are enabling open source firmware. So the first Gen 11 systems that we are shipping are based on Ampere Ultra Max ARM CPUs. So this board is running HPE UEFI implementation, ILO, and is able to run OpenBMC. And we are working at enabling Linux boot on this board. So this is probably one of the most open server board of the market currently, and the most flexible, at least. So, and we are starting shipment somewhere in October, November of this year. And that will be the exact same thing with the upcoming AMD CPUs and upcoming Intel CPUs. So we'll be releasing this product when the CPUs will be available. Thank you. Is there any questions? Do we have time for questions? I'm not sure.
So I'm very excited about the eSPI interface for the machines. Is it possible to boot the x86 from the eSPI, which would eliminate the need for things like SPI for doing rapid firmware iteration? And then as a follow-up, what are the current thoughts on customer supplied firmware for the x86?
Okay, it is totally possible to boot the x86 through the iSPI, through the eSPI, because this is the way we are currently booting it. So not that many people are aware about that, but that's the way we are currently booting it. And this is way much faster. In some way, we can drive the sign-on at a faster pace. And this is easing our updating process, because the firmware update process from the ROM is run from the ILO. And we always have the running copy in memory while we are writing to the SPI. So that's we are looking at. Regarding the SPI project, I was thinking about, I asked the question internally, hey, could we use our ASIC and just put it on the small PCBs and re-implement the SPI project using that? Because we got everything just to boot from RAM, and we also have the USB interface just to update that. So we could re-implement the DD EM100 without any issue with that. I didn't have enough bandwidth just to implement it, but that's somewhere into my task list. But we could do it. And the ASIC by itself doesn't cost money. So that is super cheap. It's way much cheaper than all the competitors that we have on the market. That's also why we are designing our ASICs. That's because we implemented only what we needed, and that's a way to save cost on all of our systems. Regarding x86, our position is slightly different than any ODMs, because HPE is still a very strong partner of all of our CPU vendors. So we have source code access to everything from Intel, AMD, and Ampere, and that's even a requirement to sell us anything, because we never know what could happen within the market. And our strategy is to remove as much as we can unnecessary things from the firmware and re-implement it the HPE way, which could be a good one or a bad one. Most of the time, we hope this is a good one. So roughly, I wouldn't say I don't care about the FSP, but I don't care about the FSP. So, because we have different solutions and different approach. Which doesn't mean that we do not provide feedback to Intel or AMD about what's going on and what they are doing. When implementing Linux boot, keep in mind, that's not a revolution, that's an evolution. So we will be reusing our PEI stack, we'll be reusing our Dixie core, and we'll be booting the Linux kernel as soon as we can. And the end user will be able just to integrate the Linux kernel into the ROM storage area and start it as a Dixie binary. We have proof of concept which are running currently, and this is a first step. So the challenge is really just to build a long-term roadmap and do not break everything. And the other thing is when we are enabling something on the ROM, we want to enable that on all of our servers. So the Ampere machine is running the same exact ROM code than the Intel and the AMD-based solution, pending the hardware-specific stuff. But 99% of the code is the exact same thing, which has been a mess because porting a 20 years legacy ROM to a new architecture has been a very strong challenge, especially this chip doesn't start in Little Indian mode, for example. And we faced a few challenges regarding this.
You mentioned that you provide a way to your end customer to switch to their own firmware stack. How do you handle the secure chain in that regard? So do the customers need to come up to you with a blob to sign by you, or?
Yes. So roughly what's going to happen is we have set up, if you go to hp.com and look for OpenBMC within the search engine, I think you will be ending up on a web page where there's a form. So you go to that web page, you fill up the form saying, hey, I want to switch my system on OpenBMC. So you will be in touch with somebody from HPE, so either a local support team or somebody from the US. And we will give you the whole process. But the process by itself will be, you need to send us some binary. We'll be signing it. And we establish a secure way to communicate between each of us. So you must have a security officer, or if you don't have one, you must elect one. So if you don't have one, you should be having one. So we will be dealing with your security officer about how to transfer the ownership. So roughly, this is exactly when you buy a home, for example. So we are just changing the owner of the systems. We are changing the owner of the home. So we are exchanging keys, and you get the full ownership of the platform. And we just need to be sure that we are giving the ownership to the right person. So that's the key thing. You might be thinking that the process is going to be boring, and I think it is going to be boring and perhaps a little bit challenging because it's new, but it's mandatory to ensure the security of your system too. So that's the key point.
So, for GXP, is there like support in QEMU or other emulators or dev kits or things like that? For
the answer is no. The main reason behind that is I tried to make it happen. So I got the basic of the GXP ASIC working with QEMU. But the challenge is that chip is also talking to many of other components inside the systems. And what I wanted to do is deliver a solution which can be reused by HPE engineers, whatever the environment they are, and without telling them, oh, you just need to update your QEMU implementation, because my engineer doesn't know how to do that. So, and I thought the QEMU approach was a good one at the early stage, but it ended up quickly to be a dead end to us. So we took a different option, saying, let's automatize the CI process, and let's try to make run open source firmware on real hardware. And let's build something which is good enough to unbrick a node and run it at scale. And we are extensively using an internal continuous integration platforms which rely on real hardware, including prototypes. So we are integrating these machines into the CI. Our upcoming Gen 11 and Gen 12 machines are also integrated into the CI. Depending on their hardware state development, they might be broken pretty often, but that's the best way to debug stuff. This is what we think. That's pretty old school, I know. I got a lot of customers telling me, I want a QEMU implementation of your GXP ASIC, but the ASIC by itself is probably useless because you really need to validate the CPLD interface and all the PCH interfaces, and it's not that easy just to keep it up to date with QEMU.
Okay, so Q&A session is over. Sorry, I'm sure you can catch Jean-Marie outside if you have more questions. So next talk starting in 1 minute.
Thank you very much.